Hello everyone. Today we are going to solve one of the commonly asked interview question known as longest path with different adjacent characters, right? So the problem statement is like we are given a tree where each node has a single character. And now the problem statement is that we need to return the longest path in the tree such that no adjacent node on the path have the same characters assigned to them. What does it mean? For example, let's say our path is BB, but this is not a solution because the adjacent characters that is B and B have are the same, right? So if you take example AE, this is a solution that is of length 2. So we need to see if there is any other better solution that is of length 3, uh, 2 or better than 2, right? So if you can see in this tree, if we can see this A, B, and C, right? And where if you see every adjacent character, that is A, B is different and B, C is different. So and then the length is 3. So uh, this is one of the possible solution. Okay, then B, C is a solution, but this length is 2, and A, B is a solution. Its length is 2. So we found that the longest possible solution was for length 3, right? Uh, Looking at this next example here, so we have this tree. Uh, if you see here, CA is different and AB is different, right? So our longest path could be C, A, and B, right? And then A is unique. A is not different; it's same. So this is not this cannot we cannot consider this as a solution, right? So we found that the longest path was for 3. Coming to the how we are representing this tree is like we are given input as a parent where each position represent who is the parent of that node. For example, for the very first node, there is no parent, that's represented as -1. The second node, if you see the parent is 0, it basically means its parent, 0th node is its parent. For the third element, also the 0th node is parent. For the fourth element, the first element is present. Fifth one also first is present, and second one the similarly, and sixth one I guess this is the parent. And then each string s represents the value at that node, right? So if you see, the very first node would have a value a, the second node, uh, that is the child of like whose parent is 0 node, would have a value b. That is, if you see here, this is since a 0 index, so the index 1 would be 1. uh, then the index 2 has a value 2, and if you see here, the index two's parent is again 0. And then index 3 would have a parent at index 1, node 1, that would be this, and then the value would be c. Okay, so and similarly index 4 would have a parent 1, parent at node 1, and then its value would be b. And index 5 would have a parent node 2, and its value is e, right? So this is how we're representing the problem. And then yeah. Now let's look at the possible solutions for this problem.
Yeah, hi. So let's look at this solution for the problem. So since a problem statement requires us to find the longest path, right? So for a given node, if you want to find the longest path that includes this node, we need to select two of its children that has the uh, longest path value, right? And then and include it to the result, which would include the parent as well, and this would be our resultant longest path, right? Or else it could happen like a parent would have only one child, or its other children are not applicable to be part of the result. So this is how we'll get our longest path, right? So just to make myself more clear, so let's take this as an example. uh, let's take this image as an example. So for example, we have our node A, which has four children, and then uh, we are assuming that we have already found the solutions for these children, where we say that A has three children whose adjacent values are whose chi- whose values are whose children values are different, right? Similarly, B has two, C has one, and D has three, right? But then since let's assume that our answer includes this A as the result, right? So as I mentioned, we need to select two of his child, two and then this parent node itself to find the result, right? So what would be those two child? So let's see how what would be those two and how do we find it. So for example, we see that this first child of A is A, right? but we cannot select this as a result. Why? Because it has same character. Similarly, we have B, which has two children. We have C, which has one, and D has three. So we chose B and D, not C, because since we need to select the two uh, largest chain of its largest chain, and then that would include our answer. So our answer. So what would be our answer? It would be like 2 plus this node 1 plus D node 3. So which is equivalent to 6. So like this is our answer, right? Now, yeah. So now we know how to find the longest path. As I mentioned, the longest path is the sum of the largest two chain of its children. So now the problem comes: how do we understand how do we find what is the value of the chain, right? So before that, we need to understand what is a chain. So a chain is like for a given tree, right? We navigate, and then chain is the longest path of the tree which has its adjacent values which are different, whose values are not same, right? So for example, in this example, um, here here we have a node p. Now if we want to find its chain, what we need to do is like we need to iterate toward each of his children, and then see which which one which path gives us the value of what is the largest path that we can find, where each subsequent or each adjacent element or the combination of parent node has a different value, right? And let's say, for example, this was 3, this was 1, this was 2, and this was, let's say, 0. 0 can't be a possible solution, so let's say this was 2. So we select uh, we would be selecting this path, and this value would be 4. Why? Because this has 3, and this would include a as well, this node p as well, and then so this will have a value 4, and then it will be propagated up, right? So since like this is a if you can understand, this is a very classical problem of DFS, where like we need to propagate towards the children, and then we need to find the longest path. So now we have the idea how to solve the problem. So now let's take an example and understand how we are exactly going to solve it, right? So we are given with a tree that we this is the tree that we taken prior as an example. So now what we need to do is we need to find the longest path, right? So we'll start with this root node, and then we will see if we can find the as I mentioned, we need to find the longest chain, right? So it's for each children we need to find its what is the chain, the value of the chain that we get, right? So this is a very simple example to start with. As I mentioned, like we would be like here, since we are traversing. So for traversal, we generally have two approaches: DFS and BFS. DFS being a little bit simpler to understand because like the recursion and all helps it there. So we would be following the approach of DFS here, right? So for A, we would be iterating for each child. So how DFS works is like we take one child, and then we take one child, and then we take that child's child, and then we just go deeper and deeper, and then we come back, and then we go to the next child of the parent that we had just taken, right? So here we take, for example, we take the first child A. Now, since it already has a child, we will go one more level deeper, and then we see that since E does not have a child, so we can assume that if only this was the solution, it would have returned 1, right? So this E returns 1. Now, since A does not have any other child, all right, so so if we consider, let's say, if this was the example, like AE, what we would get is okay, and then we have a global variable here, longest path, which explains that this is the longest value that we have achieved till now. So whenever we get a value greater than this longest path, we will be updating the value, and since this is a global variable, so it is independent of where we are right now. It just mentions that till now that we have visited, this is the longest path that we have seen, okay? And then this is the largest chain and the second largest chain. So what does it mean is that the longest path, as we mentioned, is the combination of the second first the largest chain and the second largest chain. So whenever we get that value, uh, the value of the largest and second largest chain, we if it is +1, if it is less than the longest path, or if it's greater than the longest path, we just update our longest path, right? So coming back, so if only E was there, and since our longest path is, since if there is one node, that would be the solution, and so longest path is by default defined set to 1. Now we see A, right? We come to this node A. A has only one child E, and fortunately it is different, right? A is not same as E. So like this could be one of the possible solution, right? So what happens is it propagates to all its children, that is E, and then yeah, E returns 1, right? And then it has to it like, so what happens is, since we need to include A also into the result, so whatever this children returns, it adds plus 1 to it, right? So this will have a value too. Okay. And then it is, since it is we have only one chain, that is the largest chain, we do not have the second, it does not have any other child. So if you see this 2 is greater than the longest value 1, so the longest path, so we'll update this to 2 as of now, right? And then this A will turn 2. Now so for coming and then it goes back, all right? And so for this A, now it has one child, that is, this is the one child, and this is the other child B, right? So it will propagate, it will go to B, and then B has other child. So since this is DFS, we just keep on going down, it goes to C. Okay, so since C does not have any child, it will just return 1, meaning that this, if this was one of the possible solution, if it would be 1, right? So it would return 1 to this. So this would have a value 1. Now it comes to B also has a value, like, since it does not have a child, it will have a value 1. Now since all both the childs are done, it goes back. Now for B, if B has to since we mentioned, like, it has to select one of the longest path and the longest chain, right? So since it has only one child here, and it cannot select this because B is same as B, so it will not be selecting this. So it will have these two, B and C. So this could be one of the possible answer for us. Okay. And then since this was already equivalent to 1, it will also add 1 to it. So this will have a value 2, and since our largest path already has a value 2, we just leave it. And uh, so this is also forming a chain, as in B and C, right? Now for it goes back, and then we see that all the children of A has been covered. Now we see that yeah. Now if we let's say, if we assume that A would be in the result, it will take the sum of its two subsequent children. But if we see that it cannot take the result of this A, right? Because this A and this A is similar, so this result is discarded. If, for example, we take the result, like, if we assume that we get a value that is greater than 2, all right, and then it will select the result, it will select only its child B. And then since we still did not encounter any situation where it had two children, and then we had to, or two or more children, where we had to take the two largest ones, but it's fine. So yeah, so now A, B, and C, this would be a result. So since we already know the value of B, we would be just adding plus 1 to it, and then this will have a value 3. And since it is greater than the current longest path, 3, that, and 3 would be updated, and this is our answer for this sample, right? Yeah. So let's try to take another example, in case the previous example was a little bit more confusing. So this example will try to cover more scenarios, and then yeah, it might help you in studying even better. So again, to start with, we'll start with our root node A. Then we will traverse to its child. We traverse to the first. So we are following the DFS rule, as I mentioned. We'll traverse to the first side. We go to B. Then from B we go to C. And C, since does not have any child, so this will have a value 1. And then it goes to its other child, that is, all right. Now since C has a value 1, and then it traverses to its right child, it goes D, and then D has another child D, and then this returns 1, right? Now this returns 1, and when this returns to this, right, it will not consider the result of this. So basically so this will have a value of, like, since these both are same, so the 1 is not propagated up here, and then this will have a value of only 1. If this was something different, this could have been 2, because uh, as of now, like, this is one solution, but as a whole, this is not a solution, right? Because D and D is same. So only this is a valid individual path, so this would have a value of 1, right? Now since this is equivalent to 1, this is C. So if you see, like, B may, like, what will happen is, So we can see that there is a path forming C, B, and D. Okay, all right. So and initially our longest value is 1. So now we can see that we are able to find a path that is greater than 1. So we update it to 2, right? So like what would happen is for B, it will first see what is its longest left chain is 1, and right chain, longest right chain, like second longest chain is also 1, and then it will so the longest path will have this logic which is equivalence to longest path, and this longest path, or the sum of longest chain plus second longest chain plus 1, that is equals to 1 plus 1 plus 2 3, right? So sorry, this should be 3, right? And then now when b processing is done, it should return a value to a. So it should not return 3 here, it should instead return the sum of the longest chain plus 1, that is equivalent to 2. Why? Since let's consider the example where a is also the part of the solution, right? So we cannot have a path which includes c, b, d, and a, right? Because that's not a path. A path should be like a, b, and d, or a, b, and c, right? So that's what we call. So while returning back, it should return the chain, but while processing, it should, if it considers the node, it should have the sum of its children, right? I hope I'm making myself clear here. So this will have a value of 2, right? Now again, so processing of each b child is done. It comes to the other child, that is a, right? So we know that this a will not be returning any value to a, like its parent, because they have a similar node, but it is possible that we can get an answer here, like we can get a path that is in this child node, right? So irrespective of that, we'll be transferring, we will be doing the traversal in this child node. So it comes to a, then a to b, b to c, and c to c, right? So there is no other node that returns 1, and then c has only one child, that is c. Anyways, but it can't be the part of the solution, so it will just return 1. It will also have a value 1, means only this is the valid path, not cc is the valid path, right? It comes to b. Now we can see that bc is a valid solution, right? Since c is different to b, it's not same as b, so what happens is c plus 1 it will return, that is equivalent to 2, right? And then a is and at the same time we see that a longest chain, since it does not have a second longest chain, that is 0, and it has um, I'm talking about B right now. It has only one chain, that is 1. So our longest path is equal, like it is not updating our max condition, right? Similarly, B will return 2 plus 1, that is B plus 1, that is 3 here. And since it has only one child, and uh, okay, so A will be returning 2 actually. So the value of the longest path is still 3 right now, and which is not greater than this, right? Anyways, and then this has a value of 3. And then coming to the other child of A, that is E. Um, Okay, so it will traverse to its children, since it's not the root node, and since this is 1, we return 1. Then then we have E. E is also equivalent to since it has only one child, so it will be returning 2 to its parent, right? Now and then in the meanwhile, it is not updating our criteria. So now for A, all its children has been traversed, right? So yeah, now we see that A has 3 children, B, A, and E. Out of this, A is not this A cannot be considered. Now it has we see the longest and second longest chain. So one of this chain value is 2, so we update it to 2. Sorry, this is 2, and the other children's also his value is 2, right? Now if we see our criteria of this, where we say that longest path will be equivalent to the longest path, or the sum of longest chain plus second longest chain plus 1, that is equivalent to 2 plus 1 plus 2, that is 5. So we get an answer 5. So, and this is the maximum value that we've encountered till now, and so our answer is 5. I hope this example makes it more clear. So we'll look at the code quickly, and that's how we should be able to complete this problem. Yeah, so now let's quickly look in the code, which if you know the logic, it's pretty simple to implement, I guess. Yeah, so our function starts from this code basically starts from longest path, where we're given the parent and the string, and then we create a map, which is in star, basically, where we store for each node what are its children, right? So that's what we are doing here, and then we are calling the dfs function. So here we are. So if you see, the very first criteria is like, if a children does not have a node, we just return 1, that is the children just returns 1, right? and then we have two variables which is used for storing the longest and the second longest chain element, uh, chain, right? And then what we're doing is for each node we are iterating to for each children, right? For each current node we are iterating each children, and then we are saying that we are calling the DFS, and then um, we're calling the DFS for the children basically. Again, the same process, and then we're storing the value in the longest chain starting from child. And then we say that if the value of the child is different, right? If the value of the basically if the value of child is different, we just continue, we do not do further processing. Or else what we do is alright, or else what we do is basically we need to find what is the largest and the second largest element. That's what we are doing here. All right. So we are getting the value of for each child. We are storing the value in the longest chain starting from child, and then we are saying that if that value is greater than the longest chain, that is the largest value, we make the second largest as the largest, and the largest as the largest longest chain as the value of the current value that we have just encountered. Or else this is the logic for updating the second largest element, where we say that if the longest chain is greater than the second longest element, but I guess smaller than the longest chain element. So in that case, we just need to update the second largest element, right? So after this iteration is completed, what will happen is a value, we will have a value that is that will have a sorry. After the iteration is completed, we will have the value of longest chain in the second longest chain, and then we compare it with the longest path. Okay, so if you see, this value is a global variable, as in it does not matter where this exists, like wherever we find the longest path, we'll just update it, right? And then and if you see, we are returning just the longest chain plus one, not the second longest chain or the sum of this longest and second longest chain. As I mentioned, the idea rationale behind that is, so for example, if we take a, we need to have this b and c, not the path of, like, not if we take this b node, right? It could, like, here the longest here the longest path could be c, b, and d, that is 3, but we do not need to we do not want to return 3, we want to return 2, because for the parent of b, that is a, we need to see, like, we need to form a path, right? Not this a, b, and d. I guess you hope you get the idea. So yeah, after the code completes, you should be able to get the value of the longest path. And that's about it. Thank you for watching up to here. Have a good day. Bye bye.